How does the value of an expression change when it is expanded? Think about this during the lesson. This family farm has an orange orchard. They plan to add a tomato patch to the end of their orange orchard. What's the total area of land that will be covered by the tomato patch and the orange orchard? Let's think about what information we're missing. What additional information is necessary to calculate the total area of land? We need to find the unknown quantity in the problem, the width of the tomato patch. We can designate this with a variable. We'll choose t. We can use an area model that looks similar to this drawing to represent the distributive property. Let's use this diagram to represent the areas of the tomato patch and orange orchard. Now we'll write and simplify an expression to represent the total area of the farm. How can you use the distributive property to expand the expression? We can use the distributive property to expand the expression by multiplying each term inside the parentheses by 1 5/10, and further simplify the second term. The expression that represents the total land area is 1 5/10 times t, plus 3 75/100. Since we used properties of operations to expand the expression, the two expressions are equivalent. Both represent the total land area in square kilometers.
What is the expanded form of the expression 3 6/10 times the quantity t plus 5?
Okay, so we have to expand this expression. So in the example, they explained using distributive property, which means you take the outside number, multiply it by each of the numbers or letters, variables on the inside. So in this first part, blank space would be the 3 6/10 times t, and the second would be 3 6/10 times 5. And then 3 6/10 times t is still going to be 3 6/10 times t here, and then 3 6/10 times 5 is equal to 18. And then the expanded expression is 3 6/10 times t plus 18. Now let's look at the model. At the right, we have 3 6 and 3 6/10 and then t, and that gave us 3 6/10 times t, and then we have 3 6/10 times this number here, which would be the 5 from the expression. So that's up here, and then when we multiplied the 3 6/10 times 5, we got 18. And that's it.
Use the distributive property to expand the expression x times the quantity -2 minus 5/10 times y.
Distribute the x to both terms inside the parentheses. So we have the x on the outside multiplying the -2 and multiplying to the negative and 5/10 times y. So for combining that or multiplying that, we have -2x here, and then that will equal -0 and 5/10 times x and times the y, because we had a variable that we're adding to the variable we already had for that particular term. Then our final expanded expression, we have this negative here that takes the place of that plus, so we have negative 2 times x minus 0 and 5/10 times x times y as the expanded expression. This is another expression that we're going to expand. We have
use the distributive property to expand the expression y times the quantity of -5 plus 2/3 times x minus 1/9 times y.
when they use the word quantity, they're saying that's what's inside of the parentheses. They don't say parentheses. Just wanted to point that out. The book doesn't. And so we are still using the distributive property by taking that whatever number, in this case it's a variable, and multiplying it times everything on the inside of those parentheses. So we have y times the -5 and y times the positive 2/3 x. And then we have -1/9 y, we just write on the end. Then you combine those terms and they look like this: -5 times y plus 2/3 x times y, because remember we already had an x and now we're multiplying the y, and then we still had the -1/9 times y. Then we have to combine like terms, and in this case we have -5y and -1/9 y as like terms, so they combined the two and got -5 and 1/9 times y plus 2/3 times x y. And so the expanded expression is -5 and 1/9 y plus 2/3 times x times y.
Expand each expression using the distributive property.
Let's work through A. So we have to use distributive property. T times -1 and 2/10 times W. I'm going to write -1 and 2/10 times W times T. That T gets added right into that term now. And we have T times 3. That's going to become 3 times T. And we have now expanded that expression, and there are no terms that are alike, so that is our final expanded expression. B, we have S in the quantity of -1 and 1/5 minus 3 -3.5 times T plus 2 times S. So we're going to use distributive property to multiply -1 and 1/5 times S, and that will give us -1 and 1/5 times S minus S now times -3.5 times T. So that becomes -3.5 times T S, and then you add in the 2 times S. Now you look to see if you have like terms. In this instance, we actually do have like terms. The terms are -1 and 1/5 S and the 2 times S. So we're going to combine those, and we're going to have, it's going to be positive 2 and 1/5 times S as our, I'm so sorry. So sorry, it's -1 and 2. That's going to be, it's going to be a positive 1 and 1/5 times S minus zoom down. Apologies. Minus 3.5 times t times s. And this will be your final expanded form of b.
Expand the expression negative 1/3 times the quantity of 2 minus 3 times x plus 3.
One way is to use the distributive property first to distribute the coefficient negative 1/3. So we have that negative 1/3 as the outside number that's being multiplied by each term on the inside of the parentheses. So it's negative 1/3 times 2, negative 1/3 times the negative minus 3x, and negative 1/3 times the 3. And then when you multiply each of those, you get negative 2/3 plus x minus 1. And then your final expanded expression, you have to combine the negative 2/3 and the negative 1. You get negative 5/3 plus the x, and that is your final expanded expression. Then another way, you have to combine like terms within parentheses first and then distribute the coefficient. So within the parentheses, the like terms are 2 and 3. That becomes the 5. And then you have the negative 1/3 times the 5, and then negative 1/3 times the negative 3x. And then you multiply them and you get negative 5/3 plus x is the final expanded expression. So in both scenarios, you do have the same expanded expression. It's just two ways to solve the same or simplify the same expression.
Expand the expression negative 2/5 times the quantity of 10 plus 5/6 times m minus 20 times n.
We're going to use the distributive property. And so negative 2 times 10, negative 2/5 times 10. Actually, I'm not going to write it out. Negative 2/5 times 10. We'll use a calculator. Actually, I'm going to show you it worked out. So negative 2/5 times 10. That is going to be 10/1 to make it a fraction. We're going to simplify first. Negative 5 divided by 5 is 1. 10 divided by 5 is 2. And then we have negative 2 times 2, which is going to be negative 4 over 1, which equals negative 4. So then we're going to have negative 4, and then we're going to multiply negative 2/5 times 5/6 times m, and then that is going to be, let's work that out. Instead of using the calculator, we have negative 2/5 times 5/6, and then we can multiply across or simplify first. I'm going to simplify first. 5 divided by 5 is 1. 5 divided by 5 is 1. And then we have 2 and 2 to divide this by. It's going to be negative 1. And then 6 divided by 2 is going to be 3. So then we have negative 1 times 1 is negative 1. And then 1 times 3 is 3. So then we have minus 1/3 times m. And then the last one The last one is going to be negative 2/5 times negative 20 times n, and that is going to be negative 2/5 times negative 20 n, which is 20 over 1. Then we're going to simplify first. So the greatest common factor of 5 and 20 is 5. 5 divided by 5 is 1. 20 divided by 5 is 4. And then we multiply straight across. That's going to be negative 8 and 1, which is going to give us minus 8. And then now we have to combine like terms. So the like terms we have here are the negative 8 and the negative 4. So when we combine that, negative 8 and 4, we're going to get minus 12. Oh, mistake. I'm so sorry. That was a mistake. I forgot to add my n back into that, so there are no like terms. We're done. Our final expanded expression is negative 4 minus 1/3 m minus 8